Welcome guys. Today we'll be making a differential equation plotter in JavaScript because that's the most loose language that I know. So it will be really quick, and the motivation for this project was my exams. So I have my exams starting from 18th and today is 15th or 16th, I guess. So basically I was learning differential equations and I thought, well, I should plot these equations and see the outcomes. But when I searched for differential equation plotter on Google, I didn't get any satisfactory result. So I thought I'm gonna make my own. So let's start by making a directory in projects that will be diff plotter. Let's go on diff plotter. Let's start with an index.html and let's quickly have a head and a body. Let's have a canvas. Let's give it a ID canvas. Let's also give it some style. So style with 100 dvw and height 100 dvh. So let's open that diff plotter index.html. Okay, so we opened it. Let's also have background color black. It's nice, but I'm getting these scrolls. Also, this shouldn't be it. Okay. Basically, if I enlarge the canvas using CSS, then it will result in a really crappy resolution. So that's why I'll be using JavaScript index.js. Let's go and add a script. Let's go something like script. Go with source index.js. Now let's go on index.js. Let's get our canvas. Okay, so I have set it up a basic system where we are setting the height and width. Let me just change this to something that we can actually perceive better. I'm a bit confused. Context.width should set the width and context.height should set the height, but it isn't somehow. See, I'm pretty sure this is working. Yes, this is working. I'm actually the one really dumb here. It should be canvas. I looked it up and it said me you are the man. Okay, so now it works. So let's go draw grade at 50. Let's go. So you could see here we got the lines, but let's change the background to complete black and we got ourselves some line. let's repeat this thing. So now we need to draw line for axis. So let's go with a function called draw axis. It will take in center as an object, and it will draw lines. Draw axis and the center will be center. As you could see, we got the axis right here. Let me do this. Okay, so we got our axis right here. Also, let's increase this height and width. Okay, so width is too much. Let's go with 600. Okay, this is nice. So this is our center. Okay. The grid is way too much white. I need it to be darker. So 50, 50, 50. Yeah, it is fine, I guess. And draw axis on the top. Yes. So it's nice. Now let's start from function plotter. So function plot, it will take in a function and it will plot. Let's plot a parabola. So for plotting a parabola, we need a function parabola that takes in x and returns y. So y would be x times x. Now let's plot parabola. So it plotted the parabola correctly, but it's upside down. So I guess I have to flip y. Is this what it is? Yes. So as you could see, we got parabola plotted. It's so good, man. It's so good. And let's make it somewhat small. Yes, it is now correct. So we have successfully plotted a parabola. Let's also plot sine waves. So function sine takes in x, returns math dot sine of x. Let's plot sine function. Okay, it should be sine h of x. No, what did I do wrong? Sine x should be correct, I guess. Oh, I know what did I do wrong. Let's do something like 10. Yes, it was. So I have to actually zoom in. So the thing was so small, it looked like a line to me, but it wasn't a line actually. So yeah, it's nice. So I could plot sine and all those things. Let's also plot. Now we need a differential equation plotter. So let's go something like function diff equation plotter. For a diff equation, we need derivative. Okay, so we need a function derivative. Now the derivative function, okay, just refresh this. Okay, so the derivative function should, we will be using the limit approximation for the derivative function. Let me be really clear. So what is the limit approximation? Let me tell you what happened. Okay, so let me just tell you what is derivative approximation. So derivative of a function y dash is given by limit n approaches h approaches or n approaches 0 y of x plus n minus y of x divided by n. So this is the approximation that we will be using for a derivative of a function. So let's take a function and we want its derivative at some place, right? So at some x, so we'll be returning function at x minus function at x plus some really small value. So let us take const n as this thing. So it's a pretty good approximation, function at x divided by n, and this assumes that the function is differentiable, RENTIABLE, differentiable at x. Okay, so if the function isn't differentiable, that means it has some peak or it is discontinuous. So in that cases, our approximation just falls out because no derivative exists. So yeah, first let me plot a diff plotter. So diff equation plotter actually just is a plotter, but instead of having to deal with f of n directly, it will be dealing with derivative of f of n. So it will be derivative of f of n at real x. So this is the change that you would say. But if you know the derivative of sin x is cos x, so if I have a function sine that takes in x and returns math.sine of x on 100, like x on 10, so we are actually separating the things, and let's go 10 times sin x. Let's us also pass in this thing, it should now draw actually. Okay, so diff equation plotter sine of x. So let me check where is the bug. Can I plot sine as is? Oh, I'm not able to plot sine as is too. Why? Let's remove this. I don't know where did I messed up. Let's remove this. Okay. Return 10. Oh, I messed here. It should be this thing. If I remove the equation plotter, you could see that it is actually a sine wave. Let me make it more bigger and let us reduce the frequency. Okay, so it is now pretty nice. Let's do something like 100. Oh, now it's pretty good. Okay, so this is a sine wave, but if I plot the differentiation of the sine wave, I should be getting a cos wave. Okay, this is really small. So what did I do wrong? Let me check. So this is the derivative of sine x at x. Okay, so what I'm doing actually is I'm plotting sine of x plus, and let us reduce that thing. Function at this thing minus function at x divided by n. This should work. Why isn't it working? I need a way to actually see why isn't it working. So we have differentiation of f of n. Let's go on Desmos first. Sine of x plus n minus sine of x divided by n. So this whole thing should be divided by n. Let's add a slider of n and let's set this to be super. In fact, this thing works, because if I plot sine of x, it is this, and this actually is cos of x. So for bigger n, this thing is a bad approximation, but for smaller n, it is pretty damn good approximation, so it should work. If I go t equals this thing, so yes, it should work. This plus this minus sine of x divided by n. So I have a bracket that is correct. Let's have a bigger bracket right here. Let's reload. Well, let me just go 100 times this. Oh, I understood what was the problem. The actual thing returned 100 times math sine x into cos x. So if this is the case, I should be getting, see, even when this is 100 times, the cos is actually the cos remains smaller, pretty small. And so that's the reason that I was getting smaller values right here. So if I plot differentiation of sine and just go with plot sine, we should see something similar. See, we saw it. So what it means actually is that for any equation, this thing doesn't account for the multiplication factor. Okay, so this thing isn't accounting for multiplication factor. Okay, nice. So we are now able to plot the derivative. Now for plotting a differential equation, the equations are majorly like dy upon dx is some function of y. So in our scenario it will be diff of x, diff at x, differentiation at x is differentiation of function at x actually. Differentiation of function at x will be function plus x. So we want to draw this thing. How are we going to draw it? That's the thing we want to know. Well, this video has become enough long, and I think I should make a part 2 of this. So I'll be seeing you in the part 2. Bye.